I'm going to go ahead and hit record and hit share screen. Here we go. All right, off we go. So what happens in the formal derivative is you're going to have some function f of x. Let's imagine this is my function f of x. And what I want to do is I want to kind of look at this function through the idea of what is the slope of the line between these 2 points. And so any value that I pick right here, which would be, say, something like x, comma, f of x, and I could pick some other point over here, maybe call it c, comma, f of c. I could go ahead and I could draw a line between these 2 points, and could I use this line right here as a way of estimating the slope of that curve? So from your days back in Algebra 1, Math 2, Algebra 2, how did we find slope? What was that magic formula you learned? It was y2 minus y1 over x2 minus x1. Now, this is kind of strange, so just kind of follow me how this works. But if you take a look at our idea of slope, which looks like this, what we could do is we could say that this would be f of x minus f of c over what? X minus c. So that's just the slope of this curve. Now, as it turns out, this red line, as I have it called right now, is known as a secant line. And that is actually related to the secant that you learned about last year in analysis. It's not exactly the same. But see, this would be the average rate of change. So I want to be very, very clear about this. This is the average rate of change. And the reason why it's an average is because you've got these numbers that are sitting kind of far apart. You see it? And so it's a secant because it hits at 2 different places. But if we could add a little bit of a notch to this and we said the limit as x goes to c. Now what happens if I allow x, which is right here, and you could imagine I animated the point and I made c like a magnet and I started dragging it this way and it got super duper 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 close to that. What's going to happen is when you change it and you add the limit to that, it is no longer an average rate of change. What did I do to the 2 points? I made them super duper close together, and instead of saying, oh, how fast were we going between 3 hours ago and 8 hours ago, it would be, how fast are we going right now? And this, when you do that, is called the instantaneous rate of change. So the limit is what kind of sets it apart from the other. Now, let me ask you a question. What is going to happen as x gets infinitely close to c? Look at the numerator. What would that be? That's going to be f of c minus f of c, which is 0. What's the bottom going to be? C minus c, which is 0. That's one of those indeterminate forms that we were talking about. And so we learned all those special little tricks a little bit ago. And so this one right here is actually, I started it here because I thought this would actually help. But this is actually called the alternative form. It's kind of strange that I gave you the alternate form first, and then I'll double back. But there's a reason I wanted to show you that alternate form first. So let's imagine that I wanted to take f of x is some function x squared minus 2x plus 5. Now, you guys should know that that's just a little parabola, right? Yeah. Is the Zoom going? The Zoom is going, but nobody is here. Yeah, Zoom is going, but nobody showed up yet, but I'm using it because that way I can actually video it and show it to them when they can. So anyway, I've got this little story right here. F of x is x squared minus 2x plus 5. So what do you know about the slope of this thing? Is it constant? Think about the curvature of a parabola. It's going to be negative in places, positive in places, really, really high positives, really low negatives. You know, I got all a variety, right? So the question that I have is, what is the slope at x equals 3? So here's what I'm going to have us do, is I want to find the average rate of change. So the average rate of change was going to be f of x minus f of 3 all over x minus 3. Now, please note, as I did that, I'm leaving that as an average. So what have I not put into the story yet? I haven't put a limit in there. So what's kind of cool is if you go ahead and you put all of this stuff in, there's f of x. Now I do need to find out what f of 3 is. And when I actually found f of 3, I plugged it in, I got 9. 9 minus 6 is, weird, plus 5 is 8, right? I was looking at my notes and I wrote 8 and I was thinking something different. Anyway, I got this idea. But if I've done it right, this should do something. So let's just see what happens. That's x squared minus 2x minus 3 all over x minus 3. Can you guys factor that at all for me? Does that numerator factor? Now, this is the part I liked about calculus. There's almost a hint. The bottom is supposed to cancel, so we should know before we ever even start this problem that x minus 3 better work. What's the other part? It's x plus 1. So those are going to cancel, and so it's approximately x plus 1. That's the average rate of change. Now, what's weird about that is that I've got some curve. So it's some curve like this. I don't really care where it is. And I have the coordinate over here, 3, 8, right? And here is x, f of x, some random point. Hey, what is the slope between x equals 1 and that one? Well, the cool thing is the slope would be 2, because I just said x was 1. What is the slope between x equals negative 6, some point up here, negative 6 comma something, and that point? Well, if I said x is negative 6, well, what slope did you just get? 5, right? Or negative 5, right? So literally, I didn't find one slope. What did I find? I found every possible slope, and this is the part that becomes, now notice this is average rate of change, and it's an average because I've got 2 points that are separated by some distance. You follow? But if I make it instantaneous rate of change, which is called IROC, what do we add to the mix? Is we say, I want to know what happens as x gets infinitely close to the number 3. So if I get x getting infinitely close to the number 3, I'm going to go back in time to this one right here. What happens as x gets infinitely close to the number 3? Now keep in mind, if these things don't literally touch the number 3, as long as you say it's infinitely close, we can cancel those out. So what is the slope at that place? It's literally 4. So if you made some little person stand right there on the curve, they would feel a slope in their ankles of 4. But that's not between 2 points. That's a slope at 1 point. That's kind of weird. That's an instantaneous rate of change because you just put 2 points that are infinitely, infinitely close together. So let me see if you guys can try one of those yourself, okay? So here's h of x. H of x is the equation 2 over x minus 3. And I want to know the slope at x equals, I'm going to go with 6. So let's find AROC and IROC. at x equals 6. So I kind of set it up. That's kind of the way it works. All right. So hopefully this is going to work. So, dang, fraction bust. What do I have to multiply top and bottom by to make this pretty up a little bit? I need to hit everything with an x minus 3 and a 3. So I need to hit the top with both, the bottom with both. Pen is dying, no ink left. So what happened to the top? What happened when this hits this chunk right here? The x minus 3's die, what's left? 6, piece of cake, just 6, okay? How about when the 3 and the 3 hit, that's gonna be gone, and I'm left with the 2 and the x minus 3, and the bottom, yeah, I call the denominator collateral damage. So far, so good. By the way, what was the original denominator? X minus 6, right? That's what I want to go away. So if I've done well, that denominator should go away. Well, if I put it all together, looks to me like I got a negative 2x on top. I did not give myself enough room. I got a 6, but then I add 6 to that, so it's 12. Do you notice anything right now? It looks to me that if I factored a negative 2 out of this thing, I would have this thing right here. And what naturally happened that we wanted to have happen? The x minus 6 guys are gone. So my average rate of change is this thing right here. So guys, this is my instantaneous rate of change. Is if I go ahead and I take the limit as x goes to 6 of my average rate of change, what is the answer? What is the slope as I get infinitely close to the number 6? What happens is I get really super duper close to the number 6, is it'd be 3 times 3, which is 9. So it looks to me like my slope is very close to negative 2 nines. Cool? Now, what will happen guaranteed every single time you do these things correctly? What should happen is your original denominator should do what? It should cancel, it should go away, it should become pretty, and life is much, 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 much better. You guys cool with that? Now, the bummer about this version that I gave you, this is called the alternate form. I know a lot of teachers that don't ever even show this form, but I like it. There's a reason I like it. But in every single case, you'll notice that I actually found the slope of one particular point. So in this first example, I found the slope at the point 3, didn't I? So now that I have the slope at 3, if somebody goes, oh, yeah, that's great. Now what's the slope at 2? I have to start all the way over, don't I? Actually, I do. Everything here had to do with finding the slope between any point and the number 3. In this example, it was every point and the number 6. So if I said, oh, I didn't mean 6, I wanted to find the slope at 8, I have to start my entire journey over. This is a great way of doing it because if you noticed it, did it factor pretty nice each time? It was pretty elegant. But the limitation is it only gave me the slope at one specific, perfect value. And if you ever want to change that value, then you have to start over, which leads us to the other version. This is kind of different. So this is the big one. Here we go. Now what we're going to do is something that I alluded to last week. This is just my generic curve that I always make. Yeah. This is the big one. This is the one that we're going to use most of the time. So when do I use the method that I just showed you? Only if they ever say, oh, I've got this one point I'm interested in. But if they said, I want the slope at 2, 6, and 8, then I'm going to go to this new one that I'm going to show you because what it's going to give you is not just one of the slopes, it's going to give you all of them. It's a much more powerful way, which is why most people actually gravitate to it. So imagine this is the point x comma f of x. Now, where is x comma f of x on a graph? Literally, which point is that? That's every point, isn't it? If I move to the right h, I hit the point x plus h. By the way, how far did I move over? H. So I started at any point and I moved over any distance. This is kind of bizarre. I literally moved over from any point to any other distance. Super weird. And this is now f of x plus h. So bear with me. Hopefully this is going to work out. And so if you draw the line between those, the average rate of change is going to be f of x plus h minus f of x all over. See, now do you guys see the y2 minus y1 going on right there? That's y2 minus y1, but what is x2 minus x1? Just h. That's kind of weird. So that's my average rate of change. Because what I'm doing right now is I'm honoring that h is the separation between 2 points that I've moved over. And if I want to go to IROC, what changed it from average to instantaneous? I put a limit on it, and what do I make that h? I suck those points closer and closer together, and I go ahead and add the idea that I want the limit as h goes to. What would make those 2 points really close together? Make h get super duper small. Because if h is how far you moved over, what if you never bothered to move over? It would be the slope between a point and itself, which would be instantaneous. So it's the same exact equation, but guys, this right here is the formal definition of a derivative. That's the one that I need you guys to know really, really, really well. That is the formal definition. Now the difference, what does this tell me the slope of? Not just one point, all points. When I was in your shoes, some of this stuff I did not understand the nuances of because my teacher went to this guy, never showed me AROC. So I'm going to kind of show you how this plays out. So just kind of bear with. Let's take a function g of x. And I'm hoping that you guys are going to be good with this, but let's just see how it goes. Let's go negative 2x squared plus x plus 1. Simple little idea. And let's find the average rate of change. So It's supposed to be g of x plus h minus g of x all over h. Now, if I have done something right, what is my original denominator? It's h. So guess what better go away when I'm all done with this problem? H. And in the picture, I've got 2 points, x comma something. And what does h represent? Is how far to the right I moved over and then hit the point. Cool? Now watch how this works. G of x plus h looks like this. All of this, that's g of x plus h. Right there, see it? Now what does the formula tell me to do after I do g of x plus h? It says now subtract g of x itself. Oh, now take that original function away. And why am I dividing by h? Well, you could say it's because the formula says so, but what is slope? Isn't it rise over run? And if you look at the picture that I had up here, what is this h right here? Isn't that the run? And the rise is just how different those things are. Well, guys, this is where there's a little something that comes back from your days in Algebra 2 that I did not stress very much last year. What happens if you take x plus h and you square it? Ooh, you get x squared plus 2xh plus h squared. Because remember, x plus h squared is x plus h times x plus h. And you have to do the full distributive property. And I know that a lot of people struggle with that, but I want you to watch what happens. See, your FOIL, you get x squared, right? What's the outside? xh. What's the inside? Is another xh. So you see 2 of those things, and then your last is h squared. See, I have a lot of students tell me that that's what happens when you take x plus h and square. But they miss this part, but I want you to watch for this. In the final answer, this is the part of the story that's actually the important part. And so if you missed it, your problem sucks. You can't even do it. So here we go. Let's keep going. Now, I have mentioned to you guys before that calculus is kind of like Algebra 4. This is what I'm referring to. Does that look nasty? Oh, and it keeps getting worse for a little while. Let's just see what happens. But in this problem, something really cool happened. Look critically at that numerator. Does anybody see anything nice that happens in that numerator? Do you see the 2x squared right here and the negative 2x squared right there? Could I cancel this 2x squared with this 2x squared? Is there anything else that you guys see that I could cancel out? Ooh, the negative x, the positive x. I also see the 1 here and the minus 1 here. In other words, the only terms left, what do they have in them? Oh, so what can you do if everything that is left has an h in it? You could factor it out. That was the whole point. So if we factored out an h, let's be really careful here. I have 4xh, don't I? So that's going to be 4x. Right here, what do I have? I have 2h squared, so I'm just going to do 2h. And there's a minus h right here. So that's going to just be a minus 1. Are you guys okay with that? So effectively, this became really close to the following. It's 4x plus 2h minus 1. Now again, this is all average rate of change. This to me blew me away the first time somebody showed me this, because they're like, oh, hey, by the way, what's the slope from 1 to 4? What about if I said, hey, what's the slope on the graph from 1 to 4? You know what I'm calling x? I'm calling x 1. What am I calling h? 3. From here to here, how far did I move over? 3. So if I plugged in x equals 1, I would get 4 plus 6 minus 1. Oh, the slope between those 2 points would be 9. In other words, what could I find right now based on this funny little equation? I could find the slope between what? Everything. Any points that I wanted, couldn't I? That's kind of cool, isn't it? Literally pick any two values. The first one is what I would call x, and the second one would just be like my separation between them. But now let's do IROC. What's IROC? It takes this original problem, which is right here. So notice I'm going to take my AROC version, and what do we add to it? A limit as h goes to 0 of this thing. So guys, what is going to happen as h gets super, super close to 0? What does this go to? So, guys, there's a parabola here. It was a parabola, wasn't it? What is the slope of my parabola when x is 3? If I could literally just stand on one foot, only making contact with one foot at x equals 3, what would my slope be? 11. Where would the slope be 0? You guys see that? That at 1/4, the slope would be 0. By the way, where on a parabola is your slope going to be 0? Ooh, that's another way of finding your vertex. You could look at it. Could I also say, hey, by the way, when is my slope going to be 7? Could I do that? Could I set that equal to 7 and go find it? When would the slope be 7? At x equals 2. See, the cool thing is with this instantaneous rate of change, how many slopes did we just find? All of them. So if you look at this guy right here, it is kind of a good way of going it, but it only gives you one answer. What does this give you? Is it gives you every possible answer that you could imagine. So what we're going to do is I'm going to pass this thing out to you. I can't do that. I'll put that back on a second. Sorry, I can say it. You can see if that's 4. There's 2 for you guys. That's too many. Man, hard to get my fingers back to count these out correctly. There's 1, 2, 3, and there's 1 more for you. All right. So, guys, here's the deal. I'm going to kind of try to take you through this. Okay, I'm going to give you a moment. Can you guys try this one right here? Do exactly what I just did in that previous problem. Take f of x plus h minus f of x all over h. Notice it says the average rate of change. So what is not there? There is no limit in that story. See if you can kind of hang with that a little bit. Go through that little story. And I'm going to go ahead and stop that share. And I'm going to go ahead and resume this thing right here. All right, so guys, here's the deal. When you go ahead and plug this into this equation right here, notice I still have this because I'm going to take this x plus h right here and I'm going to square it, right? So let's see what happens. So I've got a negative 2x squared. I'm going to have a negative 4xh. I'm going to have a negative 2h squared. I'm going to have a 5x. I'm going to have a 5h. I'm going to have a 9. I'm going to have a 2x squared, a negative 5x, and a negative 9. Woo! Now, my goodness, do you see how hard that is? How many places you could go wrong with all of that train of information? But here's the cool thing about this. What should give you comfort when you're done? What happened? What's good? Almost everything cancels. The negative 2x squared there's gone. The 2x squared there's gone. What else is gone? The 9s are gone. What else is gone? The 5x's are gone. And what is left is only things that involve what? And that's exactly what could happen. So I'm going to go ahead and jump down to this line. So if I divided all of these by h, I'd have a negative 4x, I'd have a negative 2h, and I'd have a 5, wouldn't I? Because that is my average rate of change. So if somebody said, hey, what's the slope between -1 and 2? What am I calling x? X is -1. What am I calling h? H is 3. So if I did that, if I plugged in -1 for x, that would be 4. If h is 3, it looks to me like the slope between those 2 points would be 3. And so I've got all of them, right? Now, here's the part that kind of gets people a little bit, is when it says this is fancy math speak for finding IROC. You see that little apostrophe there? That's read f prime of x. We do it so frequently that we've created this little shortcut that if you put a dash in between the f and the x, f prime of x, that's like go find IROC. So all we wanted to do is take the limit as h goes to 0 of the AROC. So what happens as h gets super duper close to 0? And so now you found the instantaneous rate of change for every x that you could imagine. So if it says, hey, can we find the slope of the tangent line to the curve? Now this is kind of a strange little idea. So, so you got some curve like this, right? And 2, let's see, if you plug in 2, could somebody help me out with that? What happens if we plug 2 into the original equation? If you plug in 2 into the original equation, you get, I got 11. See if I'm right. If I plug in 2 right there, I would get -8 plus 10 is 2 plus 9 is 11. So here's the deal. I have now a point. Do I now know what the slope of the line is at 2? Look right here. What is the slope of the line at 2?
-8.
At 2, it would be -3. Guys, this is the tangent line. And so it will take me just a moment to do this, but I think it's probably worth a while to do so. I'm going to show you something on Desmos. Let's do a new share over here to my Desmos screen. Let's skinny this down a little bit so you can see it. So check out what happens. We've got this function right now, y equals -2x squared plus 5x plus 9. So it's this little equation right here. And I've got some value on it, which was, what was our coordinate? It was 2, 11. That thing right there. So I wanted to know what happened at 2, 11. So y minus 11, remember point slope form, we've done a lot of this. I'm going to go ahead and put my x minus 2 right here. And what has to go right in this little hole before the x minus 2? My slope, which I found to be -3. And if you look, how did that actually hit the curve? Let's see if it does it. Do you see how it just barely glanced the curve perfectly in how many places? 1. That was the instantaneous rate of change. It was the absolute perfect, just barely glance it and off to the races it goes. Isn't that kind of cool? Okay, so what I have for you today is 2 of them. So first, let's go back to, let's see if I can do, darn thing is not being very cooperative. So you guys may remember this version right here. Does anybody in here remember what x plus h cubed is? Well, you get x cubed. You're going to want to write this down. So right here I got x plus h squared, right? By the way, I don't ever make anybody go above cubes. Cubes is as far as we go. I got x cubed, I got 3 x squared h's, I got 3 xh squareds, and I got an h cubed. That's what x plus h cubed looks like if you go ahead and do that. All right, you guys ready? So off we go. Ready or not, here we come. So I want to find the average rate of change from 2 to k. Now, that means I'm supposed to find f of k minus f of 2 over k minus 2. It says find the average rate of change between those 2 points. That's just find the slope. And that's an average because I don't know where k is, so it's just 2 points. Well, cool things happen. It's this minus f of k itself, which was, I just messed that up. Sorry, everybody. Not looking at my notes. It's f of k. That was 3k cubed minus 9k plus 6. That's f of k. F of 2, if you plug in 2, let's see, when I plug in f of 2, I'm going to write that up here. F of 2, when I did f of 2, I got 12. Now, what was the promise I made to you guys? If you have done this correctly, what has to happen every single time like magic? The denominator cancels, which is really kind of nice. So that means if I go over here and I write this down, when my job is to factor this, I already know the answer because it has to have a k minus 2, doesn't it? So see if you can help me out with what the missing pieces are. Now, there's a couple ways to do this. You know k minus 2 is a factor, right? So we could do synthetic division on the number 2 in the original problem, like we did last year. Or we could just kind of look at it. But for most of us, I think synthetic division would probably be the smarter play. So I'm going to go ahead and do that real quick. This should not surprise you. Why does it not surprise you that I got a remainder of 0? Because you were guaranteed that that was a factor, weren't we? So what happened in here is we had 3k squared plus 6k plus 3. So by design, notice everything canceled out again, and so we got 3k squared plus 6k plus 3. Now, again, that stopped right there because I don't know what k is. The slope between the point 2 and any other point would be this one right here. It's good, but it's not that good. Now, I'm hoping that you guys start to see a little pattern in this one in just a moment, because when we go average rate of change on this one, remember, this is the formal one. This is the one that's going to kind of suck a little bit. Sorry. That's why I do a cubic literally one time, because nobody likes it. I get it. My teacher made me do it a few times, but I'm only going to make you do it once. So we need to do this one time. And then I'm going to have you guys try a couple of these on your own. And then we're gonna go back and forth because I'm going to wait on the back side a little bit because it is a little tricky. So here's f of x plus h. Okay, so I always put those in braces, everybody. You see this? What is this whole thing? That is the original function f. What did I replace all the x's with? But then the formula says don't do that. What do you do after you do f of x plus h? You subtract the original function itself. Now, if we are right, if we have done well, what's going to happen is this 3x cubed here, what's going to happen? It's going to cancel. What's going to happen to the 9x? It's going to cancel. What's going to happen to the 6? It's going to cancel. Everybody's going to cancel because anything left must have what left in it? H. Oh boy. But this is why I had you write that thing down a minute ago. Here we go. So if I take 3 of these x plus h cubed guys, that's right here. I have 3 of these x plus h cubed guys. Holy smokes. Do you see why doing problems this way scares a lot of students? Does that look like there's a little bit of room to make a few mistakes? I think for most of us, if we felt like our life depended upon it, that we did that exactly right, we would be very, very scared about our future. There's a lot of places you could go wrong, and a lot of them have to do with the process of actually distributing out those, what are called binomials. So, okay, anyway, enough of the bad news. Here's the good stuff. What happened? 3x cubed gone. Where'd I go? Oh, it's right here. I just wrote it out poorly. 3x cubed's gone. 9x is gone. 6 is gone. Everybody else has an h, right? So what happens if I pull that h out of there? I'd have 9x squared, don't I? What else do I have right here? Keep in mind, we're pulling one of the h's out because we're going to cancel this h right here. What's left? That's 9xh plus 3h squared minus 9. So f prime of x just takes the limit as h goes to 0 of that stuff. And I heard Raj say, oh, it's just 9x squared minus 9 because what did we do to all the h's? We set them equal to 0. We made them go away because we can now because we simplified that denominator. Now, to finish this little story off, there's a couple of things that I wanted you to know. Back in the day, there's something going on here that I did want you to bring up. So the original problem number 1, I want you to look at this. Look at the original problem number 1. Look at the slope of this thing right here. The slope of negative 2x squared plus 5x plus 9. You see that? That was a quadratic, wasn't it? The slope was right here. What is the slope of a second degree equation? A first degree equation. You guys see it? Look at this one. The slope of a third degree equation became a second degree equation. Anybody have a guess what the slope of a fourth degree equation would be? A third degree equation. That's a nice little thing. Also, we learned back in the day that the limit of a sum, this is weird, but we did this on properties of limits, and this is why we did it. The property of limits said that the limit of a sum is the sum of the limits. Watch this. What's the slope of 5x? Think about it. What is the slope of 5x? It's 5. The slope of negative 2x squared? It's negative 4x. It's sitting right there. As it turns out, you can go out of this. So you see this? See that? That negative 9x, what's its slope? The slope of negative 9x is negative 9. The slope of an x cubed is an x squared. I'm giving you a couple little hints. Now, unfortunately, my brother told me the trick, because there's a trick, you can look at it and see it. You can do these problems just by looking at it, and I knew the trick. And my calc teacher failed me on my first test on derivatives hard, because he made me do the long version, and I wrote all the answers down correctly, but I didn't use the process. He killed me. I do need you to know this process. Okay, here's the last little piece. When is it 0? So when would the slope be 0? So I want you to think about that. When would this be 0. Well, if I factored it, it would look like this. Can you guys see what values of x would make that thing go to 0? It would be 1 and -1. But the thing is, what the heck does that actually mean? If you have a, you guys remember what cubics look like, right? It's some kind of a cubic that looks like this. Where is this point right here? Do you guys know? Why do I know that? You just found out where the slope is 0. Isn't this the only two places? Aren't those the only two places where the slope could literally 0 out? So guys, what happens if you set the slope to 0? What are you finding? From last year, we found these things. Those are our max and mins, right? So if you could ever take the derivative and set it equal to 0, you're finding the extrema, the max and the mins. So what I'm going to do for you guys right now is I'm going to actually have us pause. Don't forget that in polynomials, you have to like blow the whole thing out and actually use the distributive property to do that. However, when you're dealing with rational equations, there's sort of a different story. And what's going to happen is you're going to get very complicated fractions. So what's the story that we did when we have complicated fractions? You guys remember our friend, the fraction buster? That's what's going to be the key to these. So if we're going to do our average rate of change here, we would do f of p minus f of -1 over p minus -1, which of course in this case would be p plus 1, right? So if I have done well, what's going to happen in the final analysis of this problem is that p plus 1 what should happen? It should just go away. And then we're going to be able to see that. So f of p would be p minus 4 over p plus 2. That's f of p. Now, if I plug in p of -1, that's a little bit of unfortunate. See, if I plugged in -1, I'd get -5 on top, and I'd get +1 on the bottom. So it looks to me like I got -5. So I'm supposed to take f of p minus f of -1. So guys, what do you think I should do to simplify what that weird equation looks like? What should I hit the top and bottom by to make it look better? P plus 2. Now, this is a theme that you saw last year. Multiplying by p plus 2 was not a move to make the denominator better. What it was a move was just to make the top better, correct? So leave the bottom in factored form, because what are we hoping will happen anyway? That p plus 1 should go away if I have done well. So what's going to happen when the p plus 2 here hits that first term? I get a p minus 4, don't I? Then what happens when the p plus 2 hits the 5 is I'd get a 5p plus 10. Did I mess something up? I feel like I messed something up. Well, I got 6p plus 6 on top. Now, what was the promise that I made you? That p plus 1 in the bottom should cancel out. Does it? What do you see? What is 6p plus 6? That's 6 of these p plus 1 guys. So right away, when I took calculus, I loved that that would happen, because as soon as I could see that that canceled, what did I know? I knew I did the problem right. I knew I was in the right spot. The downside to this is what we call the alternative function, because it would only tell me the slope between -1 and some random other value. Whereas this one says, let's do the whole story. And sorry, you're not going to like this, but we're going to go ahead and do f of x plus h minus f of x all over h And I'm going to go ahead and jump right to the story here, but you see how this time, what's the fraction buster? This is going to make you really sad. It's x plus h plus 2 and x plus 2 both. This kind of sucks because you have to hit the top with this, and you have to hit the bottom with it too. Well, dang it. Does that sound like it's going to be an easy thing to do? No, in fact, that kind of looks awful, doesn't it? That's why we don't do very many of these. We will actually do one or two, and then we will abandon it. So what happens when red here hits that first term? What's going to happen automatically is the x plus h plus 2 is going to go away, isn't it? So all I'm going to have is this times this. All right, hold on to your hats, everybody. If you multiply this by that, you're going to get x squared plus hx. See, I'm going to get x squared plus hx minus 4x plus 2x plus 2h minus 8. Woo! And then when I multiply this by that, I'm going to have a negative x squared. I'm going to get a negative xh. I'm going to get a negative 2x. I'm going to get a positive 4x. I'm going to get a 4h. And I'm going to get an 8. Holy smokes. So many things that I could miss there. And I know that's really small. My apologies for that. But after I did all of that mess, did anything good happen? Oh. The x squareds are gone. This xh is gone. The negative 4x here is gone with this one here. The 2x here is gone with that one here. The 8s are gone. Wow. What's left? 6h. That's literally all that is left. But if 6h is all that is left, and the h cancels, this is what I have left. Because remember that h is going to cancel. So what is f prime? Again, I wish I'd made this much bigger so we could see, but if you add the limit as h goes to 0 to come up with it, you end up with this right here. You get 6 over x plus 2 squared, because as h goes to 0, this gets close to x plus 2 times x plus 2. So it's 6 over x plus 2 squared. Now, I did ask you a question about this. If this is the slope, tell me something about the sign of 6 over x plus 2 squared. This is kind of a strange idea. Will that ever be negative? Will it ever even be 0? This thing is always positive. That means if you take a look at this graph, it was always increasing. Now, guys, why do I know that it is always increasing? Is look at the slope right here. Could that slope ever be 0? No, because it's squared. Can it ever be 0? No, because a fraction can only be 0 if the top is 0. So that means if I graph this, this thing is always going uphill, which is strange. By the way, I won't take the time to show you the whole thing right now, but this is kind of what it looks like. So if you look at it, is it always going uphill? The only downside is it does have a vertical asymptote that kind of breaks it, but no matter where you stand on the curve, you would always be feeling something in your feet that it is going uphill. And the derivative tells us that. So what's the key if you have a fraction? fraction bust. The alternative version was pretty easy. The formal definition, it sucks, doesn't it? It's super hard. Look at how bad that is. Woo! By the way, you know the trick is on roots? We did it last year. It wasn't fraction bust, it was a conjugate. So we will deal with that next time.